of the presentation. So this is introduction to boot kits. They are basically root kits. You guys must already be knowing root kits, which allow you to root a system. Basically, once you access a system, you want to keep the root power in your hands. Root kits let you do that. However, boot kits are one step ahead of root kits. They let you become root even if you don't have access, just after you have physical access to the machine. Let's say, for example, if you can reboot a machine from, for example, say a CD-ROM drive or a USB drive or a PXE booting, you can become admin of the system no matter what security protections have been applied by the computer administrator. They are almost impossible to detect. This is because antiviruses come up when the OS is up. We attack the OS even when the OS is not started booting up. Since we start even before the OS is starting up, we can patch all the protections, defeat all the layers of security, antiviruses, firewalls, just name any protection, and we can demonstrate that it can be broken very easily. Yeah. So we use customized boot sector for attacking the systems, and however these are the formats of, these are not newly invented attacks. They were existing say 10 years down the line, but then Windows came into picture, and these complex viruses, no one even cared about writing them because they used to attack DOS. Boot sector viruses were famous for DOS, but after when these protected operating systems came, such as Windows, Linux, no one started caring about boot sector viruses, and they slowly went out of form. Even antivirus engines, I don't want to name a few companies, even they have removed boot sector virus detection from the engine itself. So now we will document the Windows x86 boot processor. x86 is the target architecture that you must all be knowing. So how Windows boots on x86? Windows first has an MBR, master boot record, which contains a partition table and all the other things necessary. It's the first sector which is executed from the hard disk. This MBR loads from the NTFS partition on which you have installed the OS. First 16 sectors or 8 kilobytes of code. What this 8 kilobytes of code does is, it finds the first file, bootmanager.exe. In case of 2000 XP and 2003, it finds NTLDR, which stands for anti-loader. Now it has been replaced by, from the Vista operating system, by boot manager, bootmgr.exe. Bootmanager.exe is the first exe to run. So it's a little special one, because before bootmanager.exe comes up, there is no one to set the environment for executables to run. So bootmanager has a 16-bit component which is executed before the bootmanager.exe is executed, which sets up everything in the memory. If there are any references, dependencies, they are solved. However, it is statically built, so there are no dependencies at this level. So bootmanager starts execution in BM main function. BM main function is the entry point. All of you have written most probably C codes, and main is the entry point. However, it has boot manager main. It's the entry point there. It used to verify itself in existing generations. Existing means pre-Windows versions from Vista onwards. However, we demonstrated this sort of attacks on Windows Vista also, and Microsoft noted the point that you cannot protect an OS at such a level, so they removed a few protections here. Now it no longer verifies whether it is valid or not, it just passes the execution to the next stage without verification. This was a comment that we gave to Microsoft, that no software in the world can detect changes to itself and declare that the results can be relied upon. If I am saying I am XYZ and I am the only proof, then it's up to you guys. It might not be real. If 10% say, okay, this is XYZ, then you have some credibility. Here we are missing the credibility. So Microsoft remove the credibility because they know that it cannot be credible. The results cannot be credible at such a point. After this, let's say you hibernated your system previous time, so it will be executed by executing the winresume.exe and booting completes. However, if the hibernation state is not found, then it has to check the database, which OS to boot, which is the original partition to boot, which is the boot partition, which is the OS partition, BitLocker is enabled, and few other things. It also displays you an entry. If you have seen that sometimes it displays, okay, boot Windows operating system, say XP, and boot Windows 7 or Windows Vista. So this selection, after you select and press enter key, bm launch boot entry is the function in bootmanager.exe which verifies everything and then loads the next stage of operating system. Earlier, all the stages were part of NT loader. They didn't have separate componentized stuffs. For example, here we have Hibernate is handled by WinResume. OS loading is handled by WinLoad, Windows Loader, and such. Earlier in pre-Vista operating systems, all the things were handled by NT loader, NT LDR. Now, Windows Loader loads. It loads the kernel, hull.dll, hardware abstraction layer, dependencies such as drivers, boot drivers, display drivers, keyboard drivers. It also loads registry hives. Registry hives, how many guys you know registry hives? It is the configuration store of Windows. All the important configuration settings are stored in this registry hives. It loads this and passes whatever it was knowing, say this partition, and passes it to the kernel in the form of this structure, loader parameter block. This structure contains all the pre-existing information, which driver, where it was loaded, which driver was not loaded, registry is corrupt, this or that. And then the control is transferred to the kernel using this function, OSL arc transfer to kernel. So this is a summary of how Windows boots. Here we are talking about post Vista Service Pack 0 versions. BIOS loads MBR, MBR loads volume boot sector and anti-boot sector, which loads boot manager loads WinLoad, and WinLoad loads kernel, hull.driver, and remaining drivers. The color combination shows the CPU mode. All CPUs are x86 compatible, and the earlier x86 versions, pre-8086 versions, they used to boot in 16-bit mode. So blue represents unknown mode. We don't know how the BIOS operates. Green shows the CPU is in 16-bit mode. Red shows CPU is in 32-bit mode. And black shows 64-bit if it's a 64-bit operating system. Otherwise, it shows 32-bit. This is how Windows 7 kernel initializes itself. It calls hull initialize BIOS, then it calls initialize display driver, then it starts the debugger. Before most of the drivers are executed, it only executes a few drivers